Hey everybody. So in class or I should say today or yesterday, depending on when you're watching this, we worked on the practice for section 4.4. It began on page 18 at the bottom. There's been videos for everything up until now, so if you haven't watched those videos, make sure you do. So again, we'll go over this in class. Today I want to talk to you about a couple other ways to prove triangles are congruent. Starting on page, and I know these look long, but really a lot of them are just fill in the blank. You have one proof that you have to do on your own. So we're starting today on page 22. We're going to, again, talk about triangle congruence, but this time, instead of side, angle, side, and side, 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 we're going to talk about first angle, side, angle, which is pretty much the opposite of side, angle, side. Instead of having two sides and the angle in between, we're going to have the two angles and the side in between, as you can see right here. So if the two angles and the included side of one triangle are congruent to two angles and the included side of another, so again, it's just the angle, the side, and then the other angle. All right. And you're not skipping any sides or angles there. All right, so let's get started. I put all the givens in here for you. All right, remember your free items. If you have the same side that's shared, which we don't in this, that's your reflexive property. Sorry, that looks like it's a little off, but that's okay. And then anytime you see vertical angles, which I see in this picture. All right, so I immediately am going to write 1 and 2 here, because those are vertical angles, so we know they're congruent, and we'll put that into our proof. So line CD and AB intersect at E. All right, that's really not anything that you can do anything with. It's just telling you that. BA bisects CD. So CD is being cut in half. So that means CE is congruent to DE, and that's going to be my first statement. CE is congruent to DE. And why did we know that? Because of the word bisect. So definition of bisect. You could say segment bisector, but definition of bisect's fine. And you have a side. All right. The other two, AC is perpendicular to CD, which means that this is a right angle, and then BD and CD are perpendicular as well. All right. So I'm going to give those a name as well. Let's call this 3 and 4. Or you could say, because there's only one angle there, angle C and angle D. All right, so we know that those are right. So if we show that those are the same, because they're both right, we already have the side and then our vertical angles, we can prove these two triangles are congruent by angle, side, angle. All right, so first we have to say that they are right. So angle 3 and angle 4 are right angles. So I haven't said they're congruent yet. I just said they're right. How did we know that they were right? That's your reason. Well, that was right here. Definition of perpendicular. And using the symbol is perfectly fine, but if you'd rather write out the word, you can. So now, because they're right, all right angles are 90 degrees. All right angles are the same. So we can say angle 3 is congruent to angle 4. And how do we know that? Right, it's an R, angles are congruent. All right, so we have a set of angles. Now, I know at the beginning we talked about 1 and 2, these two vertical angles right here. Angle 1, sorry, my mouse battery died, so I just have to kind of point out like this. So 1 and 2, that's one of our freebies. So we just need to state that they're vertical, and then we can say they're congruent, and we're done with our proof. So angle 1 and angle 2 are vertical. And that's just definition of vertical angles. It's an A. And so angle 1 is congruent to angle 2. All right, you could even say definition of vertical angles or vertical angles are congruent. All right, so now we have our other angle. And I know it looks like side angle, angle, but we don't go in that order. Go by order on the picture. So we have an angle, side. Angle is congruent to this angle, side angle. So the two triangles are congruent. We're going to prove, this is our last statement, whatever I want you to prove. So that's statement number 10. I know these are long, but that's why they're usually the big question on the Regents. It's like the essay. Triangle ACE is congruent to triangle BDE, and we prove that using, again, angle, side, angle is congruent to angle, side, angle. Okay, so all these proofs are very similar. It's just a matter of which one you have. All right, and the last one we're going to talk about today is angle, angle, side. So let's write down the ones that we have so far. So we have, and I want to see this, I'll check it in your packet, so you can prove it by side, 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 angle, side, angle. The opposite of that, side, angle, side. And now angle, angle, side. All right. And one way to remind my students that it's not angle, side, side, that spells a bad word. We don't want to be swearing in class. So angle, side, side is not a way to prove it. But these, and then there's one more called high leg, which we'll talk about next week. But those are the four main ones. All right, so side, 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 angle, side, angle, side, and angle, angle, side. We don't want to spell a bad word. Even if we write it this way, side, side, angle. It's still a bad word, forwards and back. All right, so let's look at angle, angle, side. So again, you'll have an angle, another angle, and then the side right next to one of them. Okay, so here's our givens. I did not tell you what to prove, but we're going to prove those two triangles are congruent. So JL bisects angle KLM. Angle KLM is being bisected, so that means angle 1 and angle 2 are congruent. And if you want to use the numbers, make sure you write the numbers in. You could also say angle KLJ is congruent to angle MLJ. Or just throw numbers into the angles so you can clearly see it in your diagram and you're good to go. All right, we knew that those were congruent because definition of bisect or definition of angle bisector. We have an angle. Okay, angle K is congruent to angle M. Okay, so I'm just going to mark those. It's a given, so we have an angle. So we have two angles. I don't have any other information, but what I do see is a freebie right there. Do you see the freebie? It's not vertical angles. Both triangles share side JL. So if you follow the path, you have angle, angle, side. All right, so we're just going to state using our reflexive property, we know JL is congruent to itself by the reflexive property. You use it all the time. So now we have our angle, angle, side. So we can say triangle JKL, it's a K, is congruent to triangle JML, and it was by angle, angle, side, being congruent to angle, angle, side. Okay. So let's just see what else we have here. All right, so again, these are the ways to, if you look on page 24, come on. These are the ways to prove your triangle is congruent. We've already talked about side, 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 angle, side, angle, side, angle, side, which are opposites each other, and then angle, angle, side. There is no side, side, angle because it spells a bad word. The other one we'll talk about is hypotenuse leg. That's next week. So we haven't covered that one yet. Okay, let's look at one last proof. Maybe, you know what? I'm going to end. My Chromebook's not working out. So if you want, you can get this proof set up. But we're going to go over this one. I'm going to put up another video. All right, if you have questions, make sure you ask me, and you should be working on the practice. After you watch this video, give it a try, and we'll be doing it together in class. But again, it's so important that you're watching and listening to these videos. Have a great day.